In this question, we have two satellites P1 and P2 which are moving in coplanar orbits of radius r1 and r2 respectively. We have been given the value of r1 and the time period of both the satellites. They are both revolving around a common planet of mass m. We need to find out the speed of S2 relative to S1 when both of them are closest to each other, and also the angular speed of S2 as observed by a person in S1 at the same instant. They are both revolving in the same direction. Now let us solve this question. We know that the time period is equal to 2 pi r1 upon v1. This is the time period for the first satellite. In general, we know that time period is equal to 2 pi r upon v. Let us consider a planet m and an object of mass m revolving around it with speed v. We can write gm m upon r square is equal to mv square upon r. Therefore, we get v is equal to root over gm upon r, where m is the central planet, mass of the central planet. Now we also know that time period is equal to 2 pi r upon v1, where r is the radius of the path, r upon root over gm upon root r. Therefore, when we multiply, let us whole square both sides, we get t square is equal to 4 pi square upon gm into r cube. From this relation we get t square is directly proportional to r cube. You should also remember this result for satellites orbiting a particular planet or the sun. Therefore, we know that since both of these are revolving around the same planet, therefore t2 square upon t1 square is equal to r2 upon r1 whole cube. From this we get t2 upon t1 is equal to 8. Therefore 8 square, that is 64, is equal to r2 upon 10 raised to the power 4 whole cube. Therefore r2 upon 10 raised to the power 4 is equal to 4. Therefore r2 is equal to 4 into 10 raised to the power 4 kilometers. Now we need to find out v1 and v2 so that we can find out their relative velocity when they are closest. So we have 2 pi r1 upon v1 is equal to time period of the first satellite, that is equal to 1 hour. Therefore v1 is equal to 2 pi r1 upon 1 kilometers per hour. When r1 is written in kilometers, this is equal to 2 pi into 10 raised to the power 4 kilometers per hour. Similarly, we can write v2 is equal to 2 pi r2 upon the time period, that is equal to 8 hours kilometers per hour. This is equal to 2 pi into 4 into 10 raised to the power 4 kilometers per hour divided by 8. This is equal to pi into 10 raised to the power 4 kilometers per hour. This is our answer for v2 and this is our answer for v1. Now when they are closest to each other, their relative velocity is equal to, suppose the velocity of p1 with respect to p2 is equal to v1 minus v2, since both are in the same direction. So for finding out the answer for part A, their relative velocity when they are closest is equal to this minus this, that is equal to pi into 10 raised to the power 4 kilometers per hour. Now we need to find out angular velocity of S2 as seen by an observer in S1, that is satellite 1, that is P1. Therefore, we know a formula for angular velocity, omega is always equal to v perpendicular upon r. Let me explain what these terms mean. Let me write this as r dash. V perpendicular is the relative velocity in the perpendicular direction as observed by a observer in P1. V perpendicular means relative to P1, what is the velocity of P2 in the perpendicular direction, and the R is the distance between those 2 points. So we need to find out the relative velocity of P2 with respect to P1, because our observer is in P1. Therefore, we'll find out V perpendicular of P2, that is equal to V2 minus V1 upon the distance between these two, that is equal to R2 minus R1, that is equal to V relative perpendicular upon R dash, where R dash is the distance between these two, that is equal to R2 minus R1, that is equal to 4 into 10 raised by 4 kilometers minus 10 raised by 4 kilometers, that is equal to 3 into 10 raised by 4 kilometers. We substitute the value of V2 minus V1 from here to get pi into 10 raised by 4 kilometers per hour upon 3 into 10 raised by 4 kilometers to get the answer as pi by 3 R inverse. Therefore, the final answer for the angular velocity of P2 as observed by an observer in P1 becomes equal to pi by 3 radians per R. So final answer for the relative velocity when they are closest is pi into 10 raised by 4 kilometers per hour, and the angular velocity of P2 as observed by an observer in P1 is equal to V relative perpendicular upon the distance between them, that is equal to pi by 3 radians per hour. The important thing which we learned over here is that omega, the relative omega, whenever we want to find out, this is a standard formula and is equal to V relative perpendicular upon R, where V relative perpendicular means relative to the observer, what is the velocity of the object in the perpendicular direction to the line joining them, and this R dash is the distance between the two objects.